replay the video as you need it, okay? Make sure that I'm going somewhat fast, not too fast, but I'm going somewhat fast on purpose so I can keep the video a certain length. And then you guys, again, can pause, rewind, replay as needed. Take down some notes as well on some of these things. All right, here's g of -3. What I'm going to do is substitute -3 into the x. There's only one x in there, so it's going to be a simple calculation. 3 divided by -3 is -1. It looks like I'm finished. All right, now I'm going to go to the next one. I'm going to do h of a plus 3. Now this one gets a little tricky for some of you, but all I'm doing is I'm substituting a plus 3 into the x position. So I'm going 4 and then a plus 3 here and then minus 3. I'm just substituting the a plus 3 into the x position, and then I'm just going to work it out. So I'm going to distribute 4 times a and 4 times 3. So if I do that, I'm going to get 4a plus 12, and then there's a minus 3 after that. Then to finish it off, I need to combine my like terms. The 12 minus 3, well, that's 9. So I'm going to have 4a plus 9. So just a little FYI, when I substituted a number, out came a number. Substitute a number, out comes a number. Substitute a variable or a variable expression, and you're going to get a variable expression. Okay, you're not going to get numbers because we're substituting a plus 3 into the x, so we're getting something with a. All right, I'm continuing on. Again, we'll talk more about this during class, but here we go. Example 4. We are looking at the domain of a function. Now, I am going to specifically talk about the domain of two particular functions. I'm going to talk about the domains of radical functions, and basically those are the square roots. We're going to talk about the domain of rational functions, and rationals are the ones that have some sort of variable here on the denominator. You could have anything on top, some sort of number or numeric expression on top, but in the bottom of that fraction is a variable. If you have a variable or variable expression, that's going to be a rational function. Now, I'm only going to talk about those because those are the only ones so far. See, lines go infinitely, forever and ever in two directions. There's no break in the graph, so the domain is from negative infinity to positive infinity, which means that in a line, you can substitute any number you want and you'll get an answer. In a quadratic parabola, in a parabola, you can substitute any number to the left, any number to the right. This graph goes forever and ever both ways. So the domain of a parabola is negative infinity, positive infinity. Same thing with an absolute value graph. Negative infinity, positive infinity. You don't start getting gaps in your graphs, because even cubic, polynomials, quartic, all of those, it's negative infinity, positive infinity. The domain of a lot of the functions that we studied in Algebra 2, negative infinity, positive infinity, negative infinity, positive infinity. It's not until you get to the square roots that you start getting into some issues here. See, you cannot have a negative inside the square root. So this is where I'm going to get started. For this one right here, if I want to know the domain of that expression, then basically I go inside the square root and I say, what's inside that square root? X plus 3. Okay, that x plus 3, since I don't know what x is, I have to limit what that's going to be, because x plus 3, whenever you substitute a number for x and you work it out, you're going to get a number in there. For example, if I put a negative 10 inside that x position, if I do f of negative 10, you'll have negative 10 plus 3 is negative 7. The square root of negative 7, that doesn't exist in our number system. That's in most calculators, you'll get an error message, or it'll say something like domain error, or you'll get an error message because you can't take the square root of a negative number. So what we're going to do is we're going to limit the domain. We're going to say that x plus 3, that stuff that's inside the square root, that needs to be greater than or equal to 0. You can have a 0 inside the square root. In other words, if you put negative 3 inside that x, negative 3 plus 3 is 0. The square root of 0 is 0, so that's good. You get an answer. But when you put negative 4 inside that thing, negative 4 plus 3 is negative 1. The square root of negative 1, you get an imaginary number. In Algebra 2, you covered imaginary number. That's why there's an I. It's not a real number. It's an imaginary number for a different system. So all you have to do to find the domain of anything that's radical, square root, fourth root, is you say that stuff that's inside, the radicand, has to be greater than or equal to 0. You go ahead and solve for x, so you move the 3 to the other side, and you get x is greater than or equal to -3. So the domain of that particular radical expression or radical function has to be the following domain. The domain is the x values such that the x values have to be greater than or equal to -3. And it could be any real number there. Now, if you want to give your answer in set builder, I'm sorry, that is set builder. If you want to give your answer in interval notation, then all you say is the domain is from -3 to infinity. Either one of these two is correct. That is the domain. The first one is in set builder. The second one is in interval notation. All right, I'm going to go to the next one. This is a rational equation. I don't know if you remember, but I said to solve for the rational function, you cannot have 0 in the denominator. So what you're going to do, what you're concerned with, is the denominator portion. The numerator, don't worry about it. Don't worry about the numerator. The denominator is where we're focusing on. You're going to take x squared plus 3x minus 10, and you just stop and think, all right, this is a rational one. There's only one thing that can happen. You cannot have a 0 in the denominator. So you're going to say that expression right there that I just picked, all that denominator, cannot, so you put not equal, cannot equal to 0. So basically all you're going to do is you're going to solve for that quadratic equation for the zeros. So, but instead of having equals, you have not equal. Put the little X bar. Anyways, here we go. So it's a quadratic equation just like we had on the first test. So you're going to go ahead and factor it. I'm going to go ahead and factor quickly here. You all can take your time, but I'm going to factor quickly. It's x plus 5 and x minus 2. That's the factoring of that expression right there, so that we can figure out what should x not equal to this time. See, we have a not equal to. You're solving it just like before, but you're putting cannot equal to. Well, then you set this to the cannot equal to 0 part. You move the 5, and looks like x cannot equal to -5. Do the same thing for the other one, and you'll say x cannot equal to 2. Just move the -2 to the other side. So my domain would be the following. Well, here's my answer. The domain, I'm going to go green here so it doesn't, because I know it's getting a little crowded. The domain of that one is the set of x values such that, well, let me make that such that a little better, such that x cannot equal -5 and x cannot equal to 2. X belongs to the set of all real numbers. In other words, x can be any real number, decimal, fraction, radical. It just can't be those numbers right there. All right, if you give your answer in set builder, this is one where the first time I think, that was set builder. If you give your answer in interval notation, this is one that for the first time, interval notation is not going to be that great. If you just stop and think, x can be anything to the left of -5, any number to the left of -5. It cannot be -5. It can be anything after -5, but up to 2, because it cannot be 2. And then it can be anything after 2. So if you think about it, you actually have a graph that looks like this. I'm going to put it on the bottom here. You're going to have a graph where you're saying, all right, -5 is a critical number, 2 is a critical number. I'm going to shade the possibilities. X can be anything way over there in the negative, all the way up to -5. It cannot be that number. After -5, it can be any number all the way until we get to 2. It cannot be 2. And then x can be anything after 2 as well. So if you think about it, you're getting 3 pieces in your domain. So you're going to say the domain is from -infinity up to -5, parenthesis, because we're not including -5. That's not part of our domain. And then you put in union with, and then you go everything from -5 to 2, close it up, in union with everything from 2 to infinity. All right, we'll talk more about this in class, but again, notice I don't have any brackets. See, -5 and 2 have open circles, so I have to put parentheses around those. Another thing is everything else is shaded, but when you shade to the left, well, to the left of -5, that's infinity. Infinity can't be contained. All right, so anyways, we'll talk more about it. Again, you can always replay this video at your pace. I'm going to go to the next one here. I'm going to go to the letter C. Once again, that's a radical. If you recall from example 4a, inside the radical, whatever's inside the radical cannot be negative. It has to be greater than or equal to 0. You move the 4 to the other side. I'm going to have to work down here. Move the 4 to the other side. Take the square root, plus and minus the square root of -4. That is an imaginary number. In Algebra 2, you would simplify that as x equals plus or minus 2i. The square root of 4 comes out as a 2. The negative comes out as I. In other words, what's going to mess up this function is if x is plus or minus 2i. Well, I is imaginary. It's not part of a real number system. So that means, guess what? We don't have to worry about the domain in this one. So I'm going to put the domain in black here. You're going to say the domain for letter C is the set of x values such that x equals all real numbers. And that's all you need to put. Or in the other notation, you would say the domain is from -infinity to +infinity. In other words, you can substitute any number you want inside of that x. See, here's the deal. Even if you put a negative number inside that x, because you're squaring it, it turns it positive. And a positive and a positive, it's a bigger positive. You're going to get a square root. It'll be some sort of decimal or whole number. So you're never going to run into the problem of having a negative in there. So therefore, there's no problems with the domain. The domain is all real numbers. All right, the last thing I'm going to talk about is piecewise functions. We're at 27 minutes. A little further than what I thought. Okay, the last thing is piecewise functions. A piecewise function is a function where it's made up of 2 or 3 pieces or 4 pieces. A lot of times we just put 2 or 3 pieces to the puzzle. And basically, this type of function basically says this. All right, the function f of x is going to be -4x plus 3, like that's the function, if the x value that you're going to substitute is less than -2. However, if the x value that you're going to substitute is greater than or equal to -2, then the function becomes x squared. So it's 2 different pieces. It's like a line and then a curve, you know, like it's a parabola and a line. 2 different pieces in the puzzle. Now, it's more like, let's see, this is something like that. Okay, something like that. Like it's a line at part of it and the rest of it is a parabola. But anyways, you're not going to need to know that necessarily. We just need to know how to work with these. This is the first time you see these things. So, but it's super easy. All you're going to do is to find f of -8. You're saying, well, -8 happens to be less than -2. So if it's less than -2, look at what the function says. It's -4x plus 3 if x is less than -2 and -8 is less than -2. So that means I'm going to use that top portion. All I'm going to do is substitute -8 into that top portion only and then just work it out. -4 times -8 is 32. 32 plus 3 is going to be 35. And that's it. Very easy. In other words, that function at x equals -8 is +35. It's way up there on the graph. What about the same function at -2? Well, -2 is not less than -2. It's greater than or equal. It's equal to -2. So that means you're going to substitute into the bottom portion. So you're going to go -2 squared. In other words, you're only going to do that part of it. And that's going to be pretty easy. -2 times -2 is +4. If you graph this function, you would go at -2, you would go up to 4. And that's where the curve kind of starts happening there. All right, finally, the last one is going to be f of 7. Well, 7 happens to, remember, these are x values. The 7 is an x value. That x value is greater than -2. So we're going to use the x squared again. We're going to substitute the 7 into the x squared. That's an easy calculation. That's 49. So it looks like f of 7 is 49, meaning that at your graph, if you go to the +7, and again, I guess I will go this way. For the +7, you would be all the way at 49. Okay, so it starts off as a line like this, and at some point it turns into a curve. All right, well, that is it, guys. The video took a little longer than what I expected to cover, but I hope you understand it, and if